Consider the this is given in GATE 2010. You could refer to the 2010 question. I'll just read it out and explain you. Okay, you need not write it. You please refer to some other book where GATE questions are given. Now watch it. Consider the methods used by process P1 and P2, which means they are saying that there are two processes P1 and P2, and they are willing to access the critical sections whenever needed, and they are using the critical section like this. The initial values of shared boolean variables, s1 and s2 are boolean variables, and their initial values are assigned randomly. Okay, so they are using some method like this for entering the critical section. See this, p1 is going to do this while s1 is equal to s2. So whenever s1 is equal to s2, it is going to remain in the infinite loop. See, this means as long as s1 equal to s2, it will keep on doing this while loop, right? So whenever s1 not equal to s2, it will break the loop and will get into critical section. Therefore, for p1, in order to enter the critical section, the condition is s1 should not be equal to s2, right? Similarly, for p2, the condition is while s1 is not equal to s2. When s1 is not equal to s2, it will be in the infinite loop, and whenever s1 is equal to s2, it will break the loop and will get into the critical section, right? And after that, after critical section is over, they are going to give the chance to the other one, right? And now the initial values are assigned randomly. So let's see what happens. Now there are two variables, boolean variables, which are randomly assigned some values. Now depending on the values of s1 and s2, either p1 will get a chance or p2 will get a chance. Or before making such a statement, let's analyze this first. Now the two variables are s1 and s2, right? And they are boolean variables, and they can take any values like this. One is they can be true true, or true false, or false true, or false false, isn't it? Now what happens if s1 equal to s2? When s1 is equal to s2, p1 will fall in infinite loop, but p2 can enter the critical section, isn't it? The reason is p2 will fall in the infinite loop only when s1 not equal to s2. Whenever s1 equal to s2, it can enter. Therefore, whenever p1 equal to p2, s1 equal to s2, right, the process which will be allowed to enter the critical section will be p2, isn't it? And whenever these two are not equal, then the process which will be allowed to enter the critical section is p1. So for these two conditions, p1 will be allowed to enter the critical section, and for these two conditions, p2 will be allowed to enter the critical section. Therefore, s1 and s2 at any point of time can contain any of these four cases, and for any of these four cases, only one process can enter the critical section. Therefore, mutual exclusion is definitely guaranteed, isn't it? Why? Because s1 and s2 will contain only these four possibilities, and these four possibilities are distributed in such a way that whenever any possibility happens, only one process is going to be in the critical section, right? So mutual exclusion is definitely guaranteed. Fine, that is okay. And now what about the progress? The progress is if a process that I told you, right, the dog and horse. If horse wants to eat the grass, dog should not stop it, isn't it? So similarly here, if some process wants to enter the critical section, the other process which is not interested should not stop that process, right? Now let's see what happens here. Assume that initially s1 and s2 are t and t, which means this is the turn for p2 to enter the critical section. Now p2 is having the permission to enter the critical section, but assume that p2 doesn't want to enter it. p2 is in some other place, and p2 is doing some other work, and it is not interested in entering the critical section right now. It is doing some other work either before it or after the critical section. Then what happens is, at this point of time, p1 tries to enter the critical section. No one is there in the critical section, and now p1 tries to enter the critical section, but still, because it is the p2's turn, we are stopping it. It is like this. See, now assume that there is a room, right? And now this room has two roommates, and one roommate has locked the key, right, and he is not inside, and he is somewhere else. He is not in the critical section, and now the key is with that roommate, and now the other roommate, when he tries to enter it, he will not be able to enter it because the key is with the other one, right? Because it is his turn to open it, right? Therefore, progress will not be guaranteed here. Even though there is no one inside the critical section, the process which is not inside the critical section is blocking a process which wants to get into the critical section, right? therefore progress is not guaranteed. I hope you understood this. I'm saying that if the initial case is TT, then it is P2's chance to enter the critical section, and P2 doesn't want to enter it. P2 is doing some other work, right? The reason is a program will have critical section as well as non-critical section, which means a process need not always request for the critical section. It can do some other work as well, right? So it is doing some other work, and now P1 wants to enter the critical section, but then it will be blocked because it will say that these sections will say that, see, whenever it is T and T, then it will say that yes, you have to wait here because both are equal. How long should it wait? Until the other one sets it to the other value, isn't it? Which means until the other one enters the critical section, you are supposed to wait here, and we don't know when the other one is willing to get into critical section, or in some cases it might not want to get into critical section at all. Then what happens to this process? It will continuously be here, right? So progress is not guaranteed here. So what is it? Mutual exclusion is definitely guaranteed, but no progress, right? Fine.